the more you can memorize. This morning, it is Monday morning. Here at Heartland Christian School, Johnny, Julia, and Sawyer, we are committing to finishing strong before the Christmas break. Aren't we, Rachel? We are here on a Monday morning full of smiles and joy, knowing that there are so many worse places we could be in the world. Hong Kong? Yeah, there's a lot of unrest going on there. There is a lot of worse places we can be in the world than sitting here in math fellowship with Mr. Franken on a Monday morning. Everyone got here safely. Everyone's in pretty relatively good health. Micah might be absent because the Steelers lost. I don't know. Maybe. Hopefully he's feeling well, and Ethan and Noah. But we're moving on to chapter 6. We can't just sit here in the snow. We got to move on to chapter 6. Chapter 6, called Multi-Step Equations and Inequalities. Guess what? Guess what that means? That means really you're not learning, listen to this, you're technically not going to learn a whole lot new in chapter 6. You're just going to combine a lot of knowledge you already have. So you know how to do one-step equations to solve for x by adding, subtracting, multiplying, or dividing both sides by the same thing, right? Whatever they do to the variable, you undo it, do the same thing to the other side, except now you might have to do it more than once. So the big thing you have to overcome, like many times in math, first thing the student has to overcome is the lack of desire to do it. Divisiophobia when you were younger. A lot of your problems with division were you just didn't want to do all the steps. And you resented it and you fought against division and you even, it might have been a real thing that you couldn't do it because you put up this mental block. Same thing here. It's just going to take more work than usual. Let's quickly go through page 270, this page that starts every chapter that says, getting ready to learn. Did I even say today's date? I didn't do my normal thing. I did say it's Monday, December 16th, year of our Lord 2019. Pre-algebra. All right, number 1. Fill in this blank. Don't look back. Just let's do this real quick. David, what is the sum of the length of the sides of any figure? What word do we give? Page 270. I'm sorry. Page 270. David, what word do we give to the length of the sides of any figure? Any polygon. What word applies to that? We have a special formula for rectangles and triangles, but what's the red? It's perimeter. Number 2. Stay with me here. There are 4 symbols we use for inequalities. Whoops, I just gave the answer away. Those 4 symbols are used for inequalities. What's the word inequality mean? Trick question. That they're not equal. One is less than or greater than the other. Or you could have a range of answers that it's either less than or greater or equal to, or greater than or equal to. Number 3, to divide a fraction, what do you multiply by? What's that fancy word? To divide, raise your hand. Yes? Reciprocal. Number 4, simplify this expression by combining like terms. You've got 3 terms in number 4. Which 2 terms are like terms, Jordan? Number 4. The 3, the positive 3 and the positive 4. So here's how Kiara, you all following me here? You're not even looking in your book. Number 4, you would combine that by making it negative 2x plus 7. Raise your hand if you do not understand how that becomes negative 2x plus 7. You don't understand? David, they've got 3 terms written there. All you did was combine like terms to make it simpler. Okay, number 5. Which terms are like? Cameron, without writing it down, tell me how you would combine number 5. You're going to take 4 terms and condense it down to 2 terms. What would it look like?
4x plus x and then 5 minus 1.
Okay, so tell me what that would look like.
5x plus 4.
Nice. 5x plus 4. This one's on you, Brett. Number 6. This one's a little tougher. What's that D word? When you see a value outside of parentheses, and there's more than one term inside that parentheses, what do you do with that value? Throughout the parentheses, you passing out papers, you do what? What? You distribute that value. So your job in number 6 is to take -2 and distribute it to the 3x and the +1. What do you think that's going to look like, Brett?
3x plus -1.
No. Take a -2. First, you're going to multiply that by 3x. What do you get?
-6x.
-6x. Now take the -2 and multiply it by +1. So far you got,
-2.
there you go. That's what number 6 would look like simplified. Got it, Lauren? You're not even here.
And what's the purpose?
Lauren, in Mr. Franklin's class, we have this special little phrase.
Be here now.
Do you know what it means? Do you think it's physical or mental? Rinsing quotes. Be here now, Elise, right?
Yep.
Be here now means you are totally mentally engrossed in what we're doing right here, right now on page 270, right, Casey? Casey, this is a tough one, Casey. It's okay if you get your pencil and paper out. I want to figure this one out with pencil and paper, but if you could do it mentally, that's really awesome. First thing you got to do is distribute the 5 through the x minus 4. Do that first. What would that look like? 7. Speaking of be here now, did you hear that, Sid? Make sure you're telling her today. Case, what's 5 times x? What's 5 times -4?
-20.
Okay, so you've distributed the 5 through the x minus 4, and then you've got this -x out there. Now what are you going to do with your like terms? Everybody got that? Number 7 would look like that, 4x minus 20. Everybody good? Number 8, you can get your pencil and paper out now if you can't do these mentally, but we're trying to go through these 15 real quick without having to do it on paper. Dominic, do you think you could figure out number 8 mentally? 2x minus 1 equals 3. X would be 2. Did you see what he did?
Yes.
2x minus 1 equals 3. Dominic mentally said, that means 2x equals 4 because he added 1 to both sides. Everybody see that? You're not even looking. And then he said, oh, I got to get rid of the 2 by dividing both sides by 2. So we got x equals 2. Seth, see if you can do number 9. Tough one. Maybe. First thing you're going to do is add 2 to both sides, Seth. So you got -3x equals 9. What would x be? You know it? Don't answer it. No? David? Better get the pencil and paper out. Time to get the pencil and paper out. Dominic!
-3.
-3. It looks like this. -3x plus 2 equals 7. I'm sorry, this is minus 2, wasn't it? You got to add 2 to both sides. Now you got to divide both sides by -3. You want me to write it in red, what I did there, in orange? I had to add 2 to both sides. Remember, all algebra is, put it in a nutshell, there's only 2 things you got to do. Whatever they do to the letter, you do the opposite, do it to both sides. They subtracted 2 from my variable, so I added 2 to both sides. They multiplied my variable by -3, so I'm going to divide both sides by -3. 9 divided by -3, -3. Number 10, 4 minus x equals 12. A little complicated because you got a negative x there. But what have they attached to the x term? A positive 4. So how do I get rid of that 4? So if I subtract 4 from both sides, I have negative x over here and 8 over there. How do I fix that negative x thing? What can I multiply both sides by and still have it be an equation?
1.
Not 1. If I multiply -1 times 1, I still have -1. What can I multiply -1 by to make it 1? -1. Let's say that again. In order to make this x positive, since right now it's a -1x, I would have to multiply both sides by -1. Because when you multiply two negatives, make a positive. So if I multiply this by -1 and this by -1, that gives positive x equals -8.
What? How does that work?
Because as long as you do the same thing to both sides of an equation, it's still an equation.
But how does 4 minus 8?
What?
How does 4 minus 8?
Where are you getting 4 minus 8? Here's the 4. I got rid of it by subtracting 4 from both sides, so it gave me 8. I have negative x equals 8.
She's saying check.
12 minus 4 is 8.
Oh, check it? Check it?
Yeah.
Okay. So if I go 4 minus -8, remember in algebra you don't actually subtract, you add the opposite. 4 minus -8 is actually 4 plus 8. Four minus, oh, go to the left on the number line. Wait. 4 minus means go to the left. Wait. Minus the opposite of 8. Oh, whoop, reverse direction. Brings me out to 12. If I was on the number line, 4 minus 8 would take me to the left. True?
Yes.
But that's not what it says to do. It says, did you go to the elementary program?
I did.
Was that awesome or what?
The boys
Josh.
all always like,
Yeah, that was-
that was
it was
amazing.
amazing. They're doing it for all tap on
We are.
Listen, 4 minus 8, Rachel, you would go to the left on your number line down to -4, right? Right? 4 take away. But it's 4 minus -8. That says, whoop, reverse direction. We're going to positive 12.
4 minus negative. There's 2 negatives.
Makes it positive. Because in algebra, again, you don't subtract, you add the opposite. You will.
2 negatives make a
All right, number 11. 13 equals 2x minus 3. This one should be, listen, I'm not calling on Dominic. I'm going to call on someone that I think I have to make sure they're actually tuning in here. Because this one should be easier to compute mentally. 2x plus 3 equals 13. Compute. Let's go. Everybody's brain's computing. Subtracting 3 from both sides. 2x equals 10. Dividing both sides by 2. X equals, Spencer, 5. Everybody got it?
Yeah. That was easy.
All right. We gotta jump in so you don't have a lot of homework on this. Last week before Christmas. We are jumping right in. I'm skipping what I was going to do with the your turn now, and we're going right to page 273, starting with number 4. 4 through 14. 4 through 14.
Is that 15 questions?
4 through 14, there would be 11 questions.
Yeah. Yeah, that's what I meant. That's what I meant.
As usual, here I am to help you through the rough spots. I hope.
I like doing I'm not
4 through 14, page 273, 274. Zacchaeus. Yeah, hold on. You say you need help already?
Yeah. I like these, but I'm a little. He just minus 8. Subtract 2 5.
Whoa! All of a sudden, ladies and gentlemen, I use that term loosely, I guess. David, please sit properly. 8b plus 2b minus 4 equals 6. Combining like terms. What two terms can I combine on this side?
2 and the 8.
The b's. So what's 8 plus 2?
10.
So the first thing I would write is 10b minus 4 equals 6. How do I get rid of the 4? No, it's already subtracted 4. What's the opposite of minus 4? Plus 4. So I add 4 just to one side? No, silly, it wouldn't be an equation anymore then. If I just did something to one side, would it be balanced anymore? Would they still be equal? No. So the second part of algebra is do it to both sides to maintain their equality, plus 4. So I've got 10b equals 10. Now what? How do I get rid of the 10? No. When they're written next to each other, that means they're multiplied together. What's the opposite of multiplication? Division. So look what happens if I divide by 10. What's 10 over 10? 1b. Remember to always, I don't make you write down the check, but it's always a good idea. You should at least mentally check, right, Sid? If you take this 1 and put it up here in the original, 8 times 1 is 8. 2 times 1 is 2. 8 plus 2 is 10 minus 4 is 6. Then we did it right. It should always, if you replace what you got for your variable, it should make the original statement true. How do I know I'm adding where? Here?
10 B's.
These two? Here. Because they subtracted 4 from my variable term, so I undo it by adding.
But like the 10 B equals 10.
Okay?
Like,
When the coefficient is written right next to the variable, that means you're multiplying. That indicates multiplication, so the opposite is divide.
I thought you were adding, and I don't know why I'm tired. I need coffee.
Mine's cold. Which actually ends up not too bad because I like iced coffee.
Iced coffee is good.
Just not hot coffee. Cold. Hot coffee that becomes cold isn't as good as iced coffee.
That's true. That is very true.
Let's go. More questions. Keep coming. This is fun. If you don't think this is fun, you got to check your pulse. Look, this is fun. It's like games, puzzles. Like, hey, I'm gonna find out what B is. I got B. It's fun. Sorry, I actually think it's fun. I'm not even trying to like encourage you or motivate you. I actually think it's fun.
But the negatives are really getting me on.
She thinks Punnett squares are fun. It's the same kind of fun.
I
I agree.
I like doing equations.
Zacchaeus. I cannot hear Zacchaeus. You're still talking.
How's ice coffee made? What's the difference?
What was your question, Dominic?
Oh
Shh. From science. Biology.
Is there like you do like?
Okay, not right now.
Hey, just a thing.
No questions on number 5, I take it.
After I do number 5, I'll check it.
If you didn't get a likely answer to number 5 on page 273, then you didn't get it right. If you didn't get a likely answer to number 5 on page 273. You
Oh,
better check your work. Yes. Oh.
Look at the time.
Yeah. All right, here we go. Negative n minus 9 plus 8n. It's always tricky when they give you a negative variable. All right, first thing I'm going to do is combine like terms. Guy right here is negative 9. I'm ignoring him for a second, okay? I got a positive 8 and a negative 1n. If I combine those two, what's that give me? Positive 8 and negative 1. 7, positive 7. I can only combine the like terms right now. So I'm rewriting this 7n, watch, minus 9 equals 26. Do you see why I did it that way? Okay. How do I get rid of the negative 9? What's the opposite of subtraction?
Addition.
So I'm going to add 9 here. That gets rid of it, 7n. As long as I do the same thing to both sides.
Is it
Ta-da.
1, 5?
I see what you did there.
And not, what's that again?
Is it, like, okay, so you have 7n equals 35. So then are you dividing by
Okay,
5?
what's it mean when they're written right next to each other?
Multiplication.
So what's the opposite?
Division.
Boom.
Are you dividing by
Boom.
7?
Both sides by 7.
Yeah. How'd you get the 7?
7 because positive 8 and negative 1.
Oh.
The like terms combine first. You can combine the n terms. A positive 8 and a negative 1 gives you positive 7. Yeah. Oh, sorry.
Oh. Wait, so are you always dividing by what, like, the numbers that...
It's not even new.
Are you always dividing by the number that you multiply by? So, like, 7...
Listen, question. Rach, the question is, if your variable is multiplied by something, do you always divide? Yes, you divide by, because that's how you undo it.
And then,
That's how you get it to equal 1.
And then you divide by 35 by the 7, and then you get 6.
That's it.
Oh.
Now, the last part, Dina, would be Bella is always sure to take this 5 and go like this. Negative 5 minus 9 plus
Yeah.
40 equals 26. Because 8 times 5 is 40, so I wrote it like that, right? So now I got negative 9, or negative 5 and negative 9, which is negative 14, plus 40 equals 26. Yep, sure does.
Yay.
Keep the questions coming. Which one? Numero 7. Okay, we got to work with the distributed property, M plus. All right, here we go. Number 7 is on the board. First thing I'm going to do, Jonathan, is, what's that D word? What's that property? I'm going to distribute the 3 to the M and negative 4. So this becomes M plus, what's 3 times M? 3M? What's 3 times negative 4?
12, negative 12.
Negative 12 equals 16. Combining like terms, I have a positive 1M and a positive 3M for a total of positive 1M, positive 3M. How many M's do I have?
4.
Thanks, Jonathan. 4M minus 12 equals 16. How do I get rid of the 12? They've subtracted 12, so I add 12 to both sides. 4M equals 28. How do I get rid of the 4, Dina? 4m, that means they're multiplied together. How do I undo it?
You divide by 4.
Divide both sides by 4. M equals 7.
Yay.
True?
Yeah.
What's 7 minus 4?
3,
What's 3 times 3?
6,
9.
9,
What's 7 plus 9?
16.
Boom.
Yay.
Done. What? You're done with all of them? And you had no questions? You think I'm going too slowly, don't you? Case. Number 12. Nobody asked about 10. That's okay. Number 12. Decide whether the given value is a solution of the equation. If not, find the solution. They gave you negative 10. So your job in number 12 is to take the negative 10, plug it in there for y. When you did that, you got negative 20y. And inside the parentheses, well, I'll write it out. 2y minus 5.
What number are you on? 12.
Who's talking? Zacchaeus is bothering you, Rachel?
Yes, he's fine.
No, but.
Oh, you didn't want to tell him? That was nice. All right. Rachel, we're going to find out if negative 10 is a solution to this problem. How? Just the way we always check to see if we got the right solution. Do you understand what the word solution means? First of all, I don't want to gloss over that. Because a lot of times in math, you hear words, terms, you're like, I don't even know what that means. Solution means you've solved the problem. It's what solves it. It's the solution, right? Okay. So if I stick negative 10 in here for all the y's,
We get negative 20.
negative 2 times 10 minus 5 times negative 10 plus 1 equals 25. We got to make sure that this side equals 25. So negative 2 times 10, negative 20. Negative 5 times negative 10, positive 50. Negative 5 times positive 1. So let's see if this is true. Negative 20 and negative 5. Let's combine our negatives. Negative 25 and positive 50. Bingo. Negative 10. Yes, the answer is, for number 12, yes, it is a solution. When you did number 11, Rachel, you should have found that it was not a solution. And then your job would be to find out what would be the solution. Let me give you a heads up. There's only 7 minutes left. Zacchaeus, when it comes to 11 through 14, there's 2 that aren't a solution and 2 that are. And if it's not a solution, what they gave you, you've got to find the actual solution. Lauren, please don't tell me you've closed your book again and you're not done because you're going to do it later. Spence, speeding ticket or what? You got them all right? Okay. But, good job, Spence, because guess what happens if I'm speeding down the road and it's a 65 mile an hour limit and I'm going 78 and everybody else is going 78 and the cop stops me and I say, well, what about all those cars? Does that matter?
Yes.
No!
Yeah, because cops are different.
That means you're my favorite. No.
Not necessarily. Just you're the unlucky person that day.
No, but then you work so hard.
Mr. Dragons, I'm here to show you his homework.
She's scribbling on the page.
Rachel.
No, it says no, I am bugs. And it's backwards.
Elise, question. Okay, cut.
And it's not asking me
Rachel,
to-
shh. Number 10. Tickets to the oh, I thought it was a country music concert. Tickets to the county fair cost $8. How much was the Canfield Fair this year?
I don't know.
A lot?
3. I was gonna say I thought it was $8.
A certain day.
All right.
5, 6 days.
70 people purchased their tickets in advance and the rest bought them at the gate. The revenue from ticket sales is $2,560. How many bought their tickets at the gate? How could we go about setting up? Go ahead.
You do that number divided by 8.
What number divided by 8?
The big number.
To find out how many bought them at the gate?
Yeah.
All right. How much is each ticket?
$8.
$8. Hold up. Who asked me this? Elise. $8 for each ticket. There's going to be a certain number of tickets I buy, right? So I'm going to multiply that 8 by a certain number. The other thing I know right now is the total money brought in, is this $26.50 or $25.60? $25.60. You with me so far? Okay. I also know that 70 people bought their tickets in advance. So of the total number of people that bought tickets, I got to take the total number of people that bought tickets, subtract 70 from that to find out how many got them at the gate. Does that make sense? All of y'all glossed over number 10, I don't know how, because it's kind of complicated. They got $2,560 total. Each ticket cost $8. There is a total number of tickets sold, but I have to subtract from that the 70 that were bought pre-sale. So how many tickets were bought at the gate? I put a T there. You could put a G there, whatever you wanted. So I got to use the distributive property to say 8T minus 560 equals 2560. I like the way they made it like that. So 8T equals 3120. And you divide that by 8. Right?
Yeah.
Because you have to find, you got to take away the 70 that bought tickets in advance to find out how many's left. Total tickets, 70 bought them at the gate. Whoa, who asked? Hold on. Elise. No, because that would be less money. Right? I don't want to take the 70 away. I want to add the 70. Jeez. Okay, remember when I said I like the way they made it like that? That's because this should be added. And I said I like the way they did it like that because that means I can subtract 560. That changes everything. Because it makes it nice and simple, 2,000. So it's the 70 bought in advance plus, oh man, plus the ones that were pre-sale gave you the 2560. That changes this to nice and convenient $2,000, 8 divided by 2,000. Even Brett can do that in his head.
I did the other one in my head.
Right, Brett? Yeah. 2,000 divided by 8. Even Jaden can do that in her head.
I don't know if I can.
I feel like you could. Because you know 250 goes into 1,000 4 times. So 250 must go to 2,000 8 times.
250? Are you going to?
250.
Yes. Okay. I have.
Sorry, Elise. Six. No, 5 times W minus 7. Here's 6. What's it equal?
-50.
Okay. I got to distribute the 5, Spencer, through the W and the -7. Then, Sydney, I have to add 35. Do you understand that? So if I add 35 to both sides, I have 20. You got that? Now I divide both sides by 5. And I get 4. And look, what's 4 minus 7? -3. What's 5 times -3? -15. 8 shopping days till Christmas.
Mom's already done.
8 shopping days till Christmas. However, for standard shipping, the notice went out today for standard shipping, FedEx and others. If you want it by Christmas, you had to order it, I think, yesterday or maybe today.
Yes, today.
For those of you that shop in cyberspace.
No, that's great.
Hey, wouldn't it be great if Johnny, Julia, and Sawyer all joined us on Thursday?
Not for them.
Julia.
You don't have to, but it would be nice. See ya.